Not so much.
Good. Me neither. So this will be fun. Like I kind of got it, but I
Still
kind of
iffy.
didn't.
It's one of those times when you think you got it, but then when you go and submit answers, then it's all zero.
Yeah, because I'm looking at the quiz and I'm thinking, was this what I studied? So, well, should we just do our best?
Yep.
Fortunately, it's just like 12 questions, so that's good.
Yeah. For a second, I was going to be like, actually, it's 14. And then I'm like, wait a second, those first two aren't actually questions.
Yeah, kind of little freebies. Okay, so question 3. Find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25. We're under 3 decimal places. So my thought was you're supposed to put the 90% in this normal probability applet, like the 0.90 up here.
For the area?
Yeah. I don't.
So 0.126?
That's what I'm getting. So, 0.126.
Which of the following statements is true?
My thought was the second one down. What do you think?
I mean, it's as good a guess as any.
Right. Gina wants to construct a 95% confidence interval for GMAT scores. Shows the standard deviation is 13 or 113. She collects a simple random sample size of 64 and computes the mean is 526. Use information for the next 6 questions. What's a point estimate for the true GMAT score? Oh gosh. So it's just going to be one specific value. Let's see what the formula for that is, though.
Would you... So I basically Googled how to do it.
Okay.
And it has that, like, the Greek E looking thing next to x divided by n. I'm thinking, are we dividing the mean by 64?
We do that. Good as a guess as any. So 6 divided by 4. You're supposed to round up to the next one, so it'd be like 9.
Okay.
Wait. Choose your last score.
But it would have to be a score also, and if the score is so high, I don't think it would be 9. Okay, so my calculation thing was wrong, finding the wrong thing.
Okay. Let me see.
Oh, there's another thing on here that says that the mean is, the number of the mean is the same for point estimate.
Oh, is it?
So is it just 526? I'm gonna go with that one.
So the mean is the point estimate? Yeah. Mm-hmm. That makes more sense than whatever I was saying. Okay.
Oh, and then for question 6, would it just be the normal probability applet, the number down there?
Was the margin of error from?
Yeah.
Reference? So what do you mean? What we type in that?
0.063.
Is that where you type in the area or the z-score?
Oh, I put 95% for the area, and then I put the z-score for the answer.
So I'm getting 1.645.
Wait, what?
I have 1.645.
For number 6 or number 7?
6. Are we on 6? Did you go to 7?
Sort of. I thought that for number 6 it was just the z-score down there was the answer.
Okay.
Did you have like an equation that finds confidence interval?
I don't.
Oh, okay.
What is the lower limit of this confidence interval? So Let's see. So for 7, would that just be like the answer for number 5 minus the answer for number 6? 526 minus 1 point.
I think that I found an equation for it.
Okay.
Check for a second. Okay, I don't think it's the right equation. So what was your idea for it?
Was I'm just reading something here. Yeah, so we would take the z-score from from question 6, and we take the answer for number 5, so the 526 minus the z-score, and that should be the answer from number 7. Number 8 would be the upper limit of that, so you add the z-score.
Okay. So 525.937 is lower. And 526.063.
What did you get for number 6?
The 0.063.
0.063?
Yeah, for the z-score.
Okay.
And then what would happen to the width of the confidence interval if Gina increased the sample size?
With the confidence interval.
Wouldn't it increase because there's less variation? Or like less chance of variation?
Mm-hmm. So for increasing the confidence interval, there would be more variation. If it's smaller, it's a narrow interval, so it's decreasing. So I think it does decrease, but
would the... Okay, I think you're right.
So what would happen to the width of the confidence interval if it changed? Gene changed it to a 99% confidence interval. I think that one increases.
A Bright Bulb light bulb company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? That is a good question.
Okay. Having a bells are ringing. Let's see. Okay. 95, so that would be, where would chart go? So we take 1.960. Use the standard deviation, which is 400. Divide that by the margin of error. So by 50. And then we want to square that. So it should be, let's round up, so 246.
All right.
Should be 246.
Okay, the mean salary of actuaries is 100,000 and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of significance 0.05 and those numbers. You collect a simple random sample of 36 women's salaries and find that the mean is 111,000. What is the lower limit of this 95% confidence interval?
That is, Yeah, I'm not sure. I'm kind of stuck on this one.
There's a calculator thing here. Just not sure it makes sense. I think it's 99,001.
99,001.
Wait, no, it has to be rounded to a whole number. So 99,002. I think. Could be totally wrong. I'm reading it wrong.
Yeah, you're better than I am on that part. This is losing me.
Then the upper limit would be 122,998.
And I think question 14 is just all the above.
Sure.
Oh gosh. Okay. Here we go.
Whoa, we did really good.
What?
Ha! I did not expect to get so high.
Holy cow. We almost got a B.
Yeah. Good job, partner.
Dang. Good job. What did we do right?